right, so let's kind of recap the back of these notes here. We have different regions that we can, so it says consider the region R bounded below by the curve, by this curve, and this one. We're going to find the volume with equilateral triangles. And so remember we have a bunch of little equilateral triangles stacked up there, and that's what we got. Then semicircles as the last one we did, and he was getting kind of close. The bell might have rung in the middle of it, I'm not real sure. But they're only semicircles, so this is my area formula for a semicircle. And I got to make that work in here. And to find the radius, this is the diameter, so I need half of the radius. That's how I find that. And that's how we substitute it all in and let the calculator do it all. All of these that we have done so far said perpendicular to the x-axis. Okay? So now we're going to do one that says that we are going to do this perpendicular to the y-axis. Right? So that means instead, let's see, what are these? Squares. So that means instead of going vertically, it's going horizontally like this. I have a square. It will look something like that. You get to pretend that it's 3D, but it's perpendicular to the y-axis instead of the x-axis, which means we need both of these equations set equal to x and not set equal to y. So if I have y equals e to the x, what do I do to both sides to solve for x? Natural log. So the natural log of y is going to equal x. We agree with that? Okay. So that means the blue one, because clearly the red one's the line, right? The blue one is natural log of y equals x. Then we have this y equals x plus 2. So that means x equals y minus 2. And that is the line x equals y minus 2. Everybody okay with that? All right, so we have a square, right? The base of the square, so we know that area is equal to side squared, so I need a side length. This would be the length that I want. How do I get that? Right minus left, exactly. So that means I'm going to take the natural log of y and subtract y minus 2. Do you agree with that? That is S. Okay, that's what S is. The area is equal to S squared, so that is equal to the natural log of y minus y minus 2 squared. Now, I could have distributed that negative just fine, but I also know that there were supposed to be parentheses there. I can also just leave it just like that. Okay? So I'm going to take area, and then what am I going to do with that? Integrate it, right? I'm going to integrate my area. So I'm going to integrate it, but I got to figure out from where to where, right? I don't know what these points are. That one kind of looks like it's at 3, but I don't get to guess. So I need to figure out what they are. How am I going to figure out what they are? In my calculator. So we're going to go in and we're going to add a graph. So on, one for new, no, unless you just want to. Then we're going to add a graph. So I'm going to put it, now, when we put this in here, even though we have y's in there, we have to put x's in here. Does that make sense to you? So that means I need to put those original functions in there, that e to the x, because I still have to get the right thing, e to the x, and then tab, x plus 2. Sorry, I'm having a moment here. Actually, I just lied to you. Now, if I was doing it by hand, I could totally do all that, but I lied. We got to go up and fix this. Let's start over. But why? I'm going to show you why. It doesn't look the same because we need the inverse. We need it reflected, because what we need to do is we need to find these points of intersection, but we have to look at it as the function has been turned. So just let's do this. Let's add a graph, and let's go into F1, and you're going to put the natural log of y, or the natural log of x. That's where I was going with my x's. Natural log of x, and then the next one I get the x minus 2. This is what I meant when I said you have to use the x's. So does it look the same? It doesn't look the same, does it? Because it has been reflected? Yes? Okay, so x and y change places, right? So x and y are going to change places for everything that we do because it's an inverse, right? Well, actually, it's not inverse. Sorry, I'm having this moment here, and I'm just, no, I'm doing it right. I'm doing it right. I know what I'm doing. Yes. Sorry, but it's not an inverse. I'm using the wrong words. I was like, wait a minute. All right, so do you see, though, when you look at this, and I wish I could show you this at the same time. You see how I want this y value that's really, really close to the x-axis? Because we have to graph this in terms of x in our calculator, when I look at this, I want this x value because that's going to be the same as that y value would be over here. You with me on that? Like this x value, because it's right there, is going to be the same as this y value. Yes? You could, but we want this in here because one of the reasons I want that in there is because I want to be able to integrate this. So yes, you are right. I could have totally got it from the regular graph. I could have just gotten the y values. That's totally fine. But because we're going to use this to integrate, that's why I wanted to fix it. And that's where I was saying weird things. You know what I mean? Because I was thinking about both. I was thinking, yeah, I can totally just put this in here like it is and find the y values, 100%. But then when I integrate, I don't want to integrate this in terms of x. I need to do it in terms of y. Okay? Now that I've totally confused everybody. Ask me a question to clarify. Okay, so then do you see how this, whatever this x value is, will be this y value? Right? A little bit more than 3, a little bit more than 3. Okay, so I need to find those, and those are going to be my a and b. So this is going to be a, this is going to be b. Okay? Whatever it is. So let's find those. I'm going to find this first one. So menu, 6, intersection, scroll over here. There. And remember, I want the x value, right? Which is technically my y value. I'm going to store that in A. So I put it right there, let it hover. Hit variable, 1 for store, and then A. And then I'm going to do the same thing for the other one. Menu 6, 4. See, a little bit more than 3. That's what we were hoping for. Variable, store, I'm going to call it B. Okay. Now remember, the reason this one is weird or different is because we want it perpendicular to the y-axis. And we have to do backwards things because it has to be in the calculator as x. Okay. So then I'm going to write on here, so this is going to go from A to B. I'm going to let A equal, what was it, 0.158 something, and B equal 3.146. If I've said what I'm making A and B at, then I can put A and B right here. Then I want to integrate the area, right? So this is the area. Natural log of y minus y minus 2 squared. Don't forget your dy. Some of you had some beautiful stuff set up on your FRQs, but you left, and you did the little integral and stuff, but you left off your dx, or your dy, or dt, or whatever the heck it was. Now, when we put this in the calculator, we put this in F1, and we put this in F2, right? So I'm really doing F1 minus F2. And again, in the calculator, this is dy, but we're using dx. So now I can go to I can add a calculator screen. So I'm going to add a page, add a calculator, get my integral. And notice here too, guys, if you hit that little button, not only are there integrals and derivatives, but here's your absolute value. Here's even a fraction, square roots. I mean, you can get all this stuff other places too, but it's kind of all right there. Right? So if you're looking for absolute value, it's there too. All right, so then I'm literally going to put in A and B. And then F1 of X, even though it's Y, minus F2 of X, and dx, even though it's Y. What'd you get? Is that what you got? Yep. And that equals 1.949. What questions do you have? What? Oh my God. No, see, this is, I have Scrooge all over. I know I have. You said this is what you got. This is what you got, so you can't just copy me. Yeah, so you're supposed to square it. Except now I can't get there. Oh my God. What the heck? Not the right one. It's going to make me do the whole thing over again. I can't get a square in there. Let me try it there, see what happens. Nope. I think I'm going to have to retype the whole thing because it doesn't like me. You just put more on. It wouldn't let me redo it, so. Of course, I can't control this like I can control the calculator. So, F1 of X minus F2 of X, close my parentheses, squared dx. That's my answer. I told y'all at the beginning of the year you drew this short straw when you got me. What questions do you have besides why is Miss Finnan such a flake? You good? All right. What? We're finding volume, so we're integrating area. This is what is supposed to go right here. I left this off in the calculator because I'm a moron. We good? Okay.